Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're going to start our discussion on congruent triangles, and we're going to have both diagram as well as proof problems. But we're basically going to be working towards proving that two triangles are congruent, and that's basically what's going to take up the rest of this unit. So there's a lot of ways we can do that. Today is just the jumping off point. Before we get into new material, let's do a few review problems. You have 3 questions, 1 to 3. Pause the video, try to answer them, and then join us back for a discussion. All right, it says name all the sides and angles for triangle FGH. Well, we have angle F, we have angle G, and we have angle H. You can name those with 3 letters if you want. However, it's not necessary because if we had a triangle, right, F, G, H, well, there's only one angle located at each of those vertices. So we could just use 1 letter. For sides, we have side FG, we have side GH, and we have side FH. All right, number 2 says, what does it mean for 2 segments to be congruent? Again, 2 things you could think about here. You could say we could map them onto one another. We could also say that they're 2 segments that have equal length. Any 2 segments that have equal length will be segments that we can map onto one another, which means that they will be congruent. We should actually say specifically how we're going to map them onto one another. Using rigid motions. And then they will, of course, also have the same length. All right, if we look at number 3, it says, what is true about angle K and angle L in the figures below? Justify your answer. Well, angle K and angle L are the angles without any tick mark, or without any arcs, but there are 2 other sets of angles in both triangles that are marked congruent. So we talked about this in a previous lesson, but if 2 sets of angles in 2 triangles are congruent, then the third sets have to be congruent, or the third set has to be congruent by the third angle theorem. So we can say angle K is congruent to angle L by third angles theorem. You could put your set of 3 arcs there as well. And it's time to move on. All right, so you don't see these triangles. They're not on a board, but I am going to put them on our virtual board for us. We have triangle ABC. And we're going to have triangle DEF. So take a second. How could we show that those 2 triangles are congruent, other than just saying they look like they are congruent? Okay, so again, thinking back to our definition of congruence, if we can use a series of rigid motions to map them onto one another, then they would be congruent. So you can imagine we could think about first translating D to B, right, to mark it on there. If we did that, we may get something that looks like this. Then you could think about rotating it. I'll put actually I'm just going to leave the vertices off. I think we understand the idea. Then I could think about rotating it so it looks like this. Then I could think about reflecting it over this purple line, right, to get this triangle right here, and then it would be mapped on to the blue one. So again, we could map them onto one another. Using a series of rigid motions. And if we're able to do this, and this is down here at the asterisk down here, if we are able to map two triangles onto one another, that means that they're going to have corresponding sides and angles that are congruent. So they're going to have three sets of corresponding sides and three sets of corresponding angles that are all congruent. And that's why I put those tick marks and arcs on those original triangles, just to show you that. Okay, before we get into proofs, we're actually going to do some practice with labeling congruent sides and angles based on whether they're corresponding. So when we have two triangles, right, we can write a congruency statement. We can say triangle something 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 is congruent to triangle something something something. So based off of what we have here, based off of the two triangles that we have, I want you to fill in a congruency statement that you think is true. Right, this one up here will be true. Down here, though, I want you to come up with one that's false. So again, I'll just start you off with the first one. We could say triangle CAB is congruent to triangle, and it's your job to figure out what order those letters should go in based off of where the arcs are and where the tick marks are. So that first statement I want you to think of needs to be true. The second statement, come up with one that would be false, and then think about why that one would be false. Okay, so if I start with C for my yellow triangle, I need to start with F for my blue, because those are the angles that have two arcs, which means those are the two congruent angles. Or that's one set of congruent angles. Then I move on to A, which means I need to go to D for my blue, because they both have one arc. And then I'm going to need to finish with E, because E and B both have three arcs. So when they give you all the angles, it's very easy to say, okay, the order needs to be this, this, this for one triangle, and this, this, this for the other. You just match up the arcs. Or the angle measurements. You know, if they had given you angle measurements instead of arcs, right, you could just match up the, the 80 with the 80, the 70 with the 70, and the 30 with 30. All right, one that's false, and there are many different options here, but let's say I kept it at CAB. Well, what if I did DEF, right? C and D are not congruent angles, so they cannot go in the same spot. And it doesn't matter what I have after that, because as long as one set of angles are not correct, it doesn't matter if the other ones are correct or not correct, the entire congruency statement is going to be false. All right, let's do some more practice. Let's see here. So let's do the top number one. You need to come up with the angles and the sides that are congruent. And you'll notice here that you're not writing the triangle congruency statement. They give you that up here. And they also give you a picture of what those triangles look like. So based off of the triangle congruency statement and the picture, what angles should be congruent, which angles are corresponding, and which sides are corresponding and congruent. All right, so I'm going to pick one angle. I'm going to pick angle R. We'll start with that one. And you'll notice in the picture, it looks like R is next to Z, right? But that doesn't necessarily mean that those are the two corresponding angles, right? the picture doesn't really tell us because there's no arcs in the picture. So we have to look at the congruency statement up here. And if R is in the first position, then that means it is corresponding and congruent with X. S is in the second position, so that means it's corresponding and congruent with Y. And T is in the third position, which means it's corresponding and congruent with Z. So this is what's important to look at, the congruency statement. If you're just looking at the picture, then you may or may not get the answer right because you're going to be guessing. You don't know which angles are congruent because they don't give you the arcs. If you look at the statement, you know exactly which angles are congruent because it matters on the order that they're written in. If we do sides, same idea. RS is in the first two positions for the first triangle, which means it corresponds with XY because they're in the first two positions. Then if we go with ST, those are in the last two positions, so we go with YZ for the second triangle. And the last set of sides would be RT, first and third position, corresponding with XZ, first and third position. So what I'd like you to take away from this is that it's extremely important to pay attention to the congruency statement because that gives you all the information you need about which angles and which sides are congruent. Sometimes the diagram doesn't tell you or give you complete information, but that congruency statement, all you have to do is match up the letters. That will tell you what angles and what sides are congruent. All right, let's do one diagram problem where we're finding missing measurements, and then we will do some proofs. All right, we'll do number 1 here at the bottom. So it says, given triangle ABC is congruent to triangle DEF, let's find the value of X and find the measurement of angle F. So if we just looked at the diagram, again, we may not be sure which angles and sides are equal. So we need to take a look at the congruency statement. All right, let's find X first. So if I'm looking at this side BA, well, that is in the first two positions of the first triangle, right? AB is in the first two spots. So if I want to match up the first two spots of my second triangle, well, it's going to be DE. So I got to come over here and look at DE, which is equal to 10. So that's how I know that those two sides must be the same length. Then I can set up my equation. So I'm going to get 2x minus 2 is equal to 6. I'm going to get 2x is equal to 8. And I'm going to get x is equal to 4. So now I'm asked to find the measurement of angle F. And again, the easiest way is probably going to be to figure out what angle F is corresponding with and congruent with from our first triangle. So I'm going to look at F. It's in the third spot of our second triangle, which means I'm going to look for the third angle in our first triangle, which is C. So unfortunately, C is not given a measurement in our first triangle. We do know they're congruent though. But the first triangle is a little bit easier to work with because we are given 2 out of the 3 angles. Sorry, I was trying to fix that to one arc. There we go. So we're given 2 out of the 3 angles, which means we should be able to find the measurement of angle C. And if we know the measurement of angle C, we can go find the measurement of angle F. The reason we have to start with the first triangle is because for the second triangle, we only know one angle. So we can't use the triangle sum theorem with that triangle because we'd have 2 unknowns. So the measurement of angle C plus 53 plus 90 is equal to 180. Then we get the measurement of angle C plus 143 is equal to 180. And the measurement of angle C is equal to 37 degrees. We then know that the measurement of angle C is equal to the measurement of angle F because those 2 angles are congruent. So we get the measurement of angle F is also equal to 37 degrees. And again, you could write that where the measurement of angle F is on the left side, but it does not matter. All right, we are going to skip number 2 for now. We're going to jump to a proof. where we try to prove that triangles are congruent. First question that we need to ask ourselves before we jump in is, what are we actually going to have to show? So if I want to prove that two triangles are congruent, so if I have triangle ABC and triangle DEF, and I want to show that triangle ABC is congruent to triangle DEF, well, before I can say that they're congruent, I'm going to have to say that they have three sets of congruent angles. I'm just going to do these randomly. And they need to have three sets of congruent sides. Oops. I was going to say, these right angles I have in there, right angles are congruent, so I wouldn't need to put three arcs. However, in our proof, we are going to go ahead and prove that every angle is congruent rather than just saying that they could be right, because we may not have, you're not always going to be proving right triangles congruent. You may be proving non-right triangles congruent as well. So we need to prove those 6 different things. We must prove that 3 sets of sides and angles are congruent. So again, it may help you, and we'll talk about this when we prove it. It's going to help you to keep track of those things, right? There's 6 things we have to prove before we can prove that the triangles are congruent. So you need to make sure you hit all 6 of those in your proof before you're at the end. But I digress. Let's jump in and do our first triangle congruency proof. So it says, given angle P and angle M are right angles, and then we know that R is the midpoint of PM, and we are also told that PQ is congruent to MN, those 2 segments, and the segments QR and NR are also congruent. So they have labeled everything in there for us, so we don't have to go put our tick marks or put our right angle boxes in there. So we can jump to our proof. First thing is going to be given, right? Everything was stated. Now, this next row is something we haven't talked about so far. Remember up above when I drew those 2 triangles, I said sometimes we may not always be proving that right triangles are congruent, so I'm going to put the 3 tick marks. Well, in this case, we are proving that right triangles are congruent, but we still have to show that those right angles are actually congruent to one another. And the way we do that is through the right angle congruence theorem. So I can say, right, if I know that P and M are right angles, then I can say that angle P is congruent to angle M by the right angle congruence theorem. So that's a new one for you. Make sure you add that to your toolbox of reasons that can be used. Now, before I go any further, I want to start keeping track of how many sets of sides and angles have I already proved congruent. Well, I have 2 sides from my given, right? So I have an S and an S. Remember, the right angles, we have to actually have a reason for why they're congruent. So I can't just use the given for that. That's why I had this line right here, but this will count as one of my angle congruency statements. So I have 3 out of the 6 that I need before I can jump to my congruency statement down below, my triangle congruency statement. All right, let's look at the next statement. It says angle QRP is congruent to angle NRM. Well, we need a reason for why they're congruent, and it may help if we label those on the diagram so that we can see, their positioning, and maybe that'll help us recognize a relationship between them. So QRP, it's not a great color. Let's just do black. So QRP and NRM, so those 2 angles right there. And maybe when you check out the diagram, you notice that those are vertical angles. So, vertical angles theorem. Okay, that is going to count as another set of angles proof congruent. So we have 2 and 2. We need one of each. Now they're saying that angle Q is congruent to angle N. So these two angles up here. Well, you may think those could be alternate interior maybe, right? If we think that these are parallel lines, those two angles are inside the parallel lines and they're on opposite sides of what you might consider this to be a transversal. The problem is, right, we were never told that these lines are parallel. So we can't make that assumption, and thus we can't use alternate interior angle theorem. So we need another reason. Well, remember that these are the third set of angles, right? We've already proved two sets of angles congruent, and when we just are left with our third set, we can use the third angles theorem. Because if the first two sets are congruent, the third set is also going to be congruent. It has to do with the triangle sum theorem. So we are all done with our angles. You see we have 3 angle congruency statements done. We've knocked them all out. We just need one more side. So it says PR is equal to MR. Well, how do we know that? Right? If we look at our diagram, we have PR. They're saying that is equal to MR. But what's the reason for that? It doesn't have tick marks on there yet. Well, we have to go back up to the given. It tells us that R is the midpoint of segment PM. So these two segments are equal by the definition of midpoint. Now, if I know that the two segments are equal in length, I can say that they are congruent, which is our next statement down here. Segment PR is congruent to segment MR by the definition of congruent segments, right? We're allowed to go back and forth between segments being equal and segments being congruent using the definition of congruent segments. Well, that was our third S. So I've proved 3 sets of sides congruent. I've proved 3 sets of angles congruent. I am ready to prove my triangles congruent. And it says triangle PQR is congruent to triangle MNR. This is just the definition of congruent triangles. And we are done. All right, so I know they gave you the statements in this proof, right? So you didn't have to do too much thinking about those. You just had to come up with the reasons. But when you have to write a proof completely on your own, it's really important to think about, have I done all of my 3 sets of sides? Have I done all 3 sets of angles? And that's why I'm using those little S's and A's just to help us keep track. But you have to have all 6 before you can say that the triangles are congruent. All right, I think that is going to do it for this lesson. We're going to hold off. Yep, we're going to hold off on that proof for now. We're going to end it here. We are past 20 minutes. So enjoy the rest of your day, and I will look forward to seeing you for our next lesson, where I'm going to teach you some shortcuts to prove triangles congruent.